Hi, thank you for joining today. I'm going to start with a short video while I introduce myself. So my name is Demetris Shammas, for those who don't know me, and I'm here to show you what I've been doing for the last few months here at Cyens Thinker Makerspace. First of all, I'm an architect and a new media artist. I work with computational processes on geometry and on image, and I find ways of bringing them into the physical and material, either as spatial experiences, like in this case. This is a project I worked on last year in Poland, in Warsaw. It's a 4-channel video installation of 9 by 9 by 6 meters of this forest-like alien landscape. I worked on this with my friend Michael Hansmeyer, and it ran for a month at this museum. The fact that I'm also a programmer means that I'm working a lot with mathematics, with patterns, with geometric operations in space and on 3D objects in ways that often result in formal complexity in the way things are expressed, or hyper complexity in this case. And very often my medium is just light, so when I work with projections or light installations, video installations, I'm interested in finding ways to either emphasize or hide aspects of an architectural space and create certain atmospheres, certain ambience. This is from a project a few years ago it was an audiovisual performance. It's a building from Ptolemos Michailidis, this one. This is a project that we worked on a couple of years ago at Cyens Ithaca with Kleanthis. It was presented at the Expo in Dubai in 2021, 22. I don't know, the Expo was postponed for a bit. And this is actually the largest full dome projection set up in the world. It's a dome with a diameter of 130 meters. So technically it was a bit challenging. Sometimes my medium is a bit more tangible. So I work with methods of fabrication, in this case, 3D sand prints. This was from a residency I did in Vienna, and I worked with algorithms that were trained on this set of 3D models and were able to imagine new forms that came from this data set. And sand printing is what you see here. It's actually depositing a layer of sand and then a layer of a binding agent selectively in this certain shape, and alternating between these two layers in order to glue the sand grains together, basically, and get this solid object that you then uncover from the box of sand, and you clean it from the loose sand. This was for a project I did at ETH Zurich, where I worked for a few years. It is a large-scale architectural application. So the sand prints were used as formwork for a concrete slab. So concrete was sprayed onto this formwork. Concrete as thin as 15 millimeters, so the slab is extremely thin. And then the only solid part is these ribs that are casted afterwards. It's what you see here. So this slab was a really long project. I designed what you see when you're in this room, and we have these 11 strips that were assembled on site and post-tensioned on site. And overall, this slab is actually, it weighs 70% less than if it was a solid concrete slab. So that was the main thing. It's extremely lightweight. And then you can do big cantilevers with this method. So now I'm gonna take you through what I was intending to do for my residency, but also what actually happened, because these are two different things. There were a lot of setbacks on the way. There were some findings that actually shaped the way the project was moving forward. When I came here, I wanted to work with ceramic 3D printing. Because I was anyway familiarized with 3D printing, but I was really interested in the material as well. I had worked on it with hand building projects, wheel turning, and I wanted to integrate computational processes with the properties of clay. And I had this obsession of trying to simulate weaving patterns, or somehow create objects that embody the essence of textiles or of basketry, basket making, while allowing this interplay between the movement of the machine, which is programmable and is 100% predetermined, because you program certain positions for the machine to move, and combine that with the unpredictability of a material that is soft, and it has plasticity and certain behaviors under gravity loads. So it somehow influences the final form in a way that you cannot really design. So when I mention weaving, I don't mean it in the literal sense. Where is Teresa? Okay. I just mean more like derailing from what is traditionally considered a 3D printing. So with 3D printing, you have this solid volume, let's say a cylinder in that case, and then you run it through software that slices and finds the contours of this object so that the machine can follow the contours and recreate your geometry. What I wanted to do is somehow reimagine the object as a line in space, as a thread that is able to move freely and or possibly intersect with itself. And I mean, that's some exaggeration, because that if you print that, it's going to fall apart. But it's just to make my point. The machine I worked with is the paste extruder. It's this machine in the exhibition space. It is a custom machine that was built here at Think Your Makerspace, mainly by Stratis Pandelidis and Marios Charalambous, I think. Not sure. And Alex. It is a basic XYZ type axis type of CNC machine. So you program positions in space where this cartridge that's being carried is gonna go, and then you program how much of a paste material that is inserted in this cartridge is gonna be extruded. So this is the cartridge where the material goes, and the paste, in my case clay, is being pushed through the tip, through this nozzle, by this plunger with a really long screw. So the material actually goes beneath this plunger. Everything okay? So a few things about the material and the preparation of the material. The consistency of industrial clay, I think we already discussed this in the other room, but it's not really suitable for 3D printing because it's not soft enough. So I would follow this process of soaking the clay for a few days and then like compressing it by hand and adding more water until I got to a toothpaste-like consistency. Sometimes it took several days to get there. So this is fast forward. And then I used this technique of slamming clay together in this multi-layered sandwich sort of technique that I learned from hand building to remove the air that might be trapped in the clay, because you don't want air in there, because if you fire it, then it expands and cracks or explodes. And also, if you have air while printing, it explodes on the soft print, so it basically destroys the print. Then these spheres are being compressed in the cartridge. And then I would assemble the cartridge onto the extruder frame and start printing. It looks easier than it is. It's not this easy. The clays I mainly worked with contain grog, which is pre-fired ceramic powder that's mixed in the clay, and you feel it. The clay has a texture, and this is to it makes the clay less sticky, so it's easier to move through mechanical parts, and also it gives the objects more structure, because anyway I'm making the clay more wet, so I need this structure for the objects not to collapse. Yes. So in the beginning, I had problems with the clay consistency. So the results were not so elegant. Sometimes not elegant at all. Some are kind of nice. But overall, you need to get to a consistency that's not that's soft enough to go through the machine and out the nozzle, but not too soft, so that you avoid this sort of results. And it came down to getting a feel for it. So I would actually evaluate it by hand. You can also, there's also moisture meters that calculate this range, but they're pretty expensive, so I decided not to get one. So I would evaluate it by hand always. Besides the consistency of the clay, I also it came down to calculating the right amount of material to extrude. So what you see here is a cylinder of the paste material as it comes out of the nozzle. And if we assume that this material is being deposited in layers, for example, then you have these consecutive layers, and then the surface area of the section of each one of these layers it should be equal to the area of the section of the cylindrical extrusion that comes through the nozzle. This I'm saying should be, but this is actually let's say our default setting, what we start with. Of course, these circles are tangent, so this would fall apart. And the solution for this is to reduce the layer height and have a layer height that is smaller than the diameter of this circle, so that the layers are sort of compressed. And in this case, the material finds ways to cover the rest of the remaining section, so that again, the area is equal to the area of that circle. This would be like my default settings, and then I would start playing with the amount of the extrusion. So while the nozzle was traveling the same horizontal distance, I would program it to extrude more or extrude less in order to get different thicknesses. So this actually, it changes the thickness of the object and also changes the weight. So this is something I used a lot. So most of my objects have more weight towards the bottom, which helped during building. This is something that's also used with wheel throwing. Yes? Because it's a way to help your object not collapse. Now I'm gonna just take you through the basic weaving approach. This would be the way objects are being printed normally. You have a software that slices through the object, creates contours, and then the machine would follow these contours and extrude any material. Like plastic 3D printing works in this way. What I wanted to do is skip the slicing software. So, hi. Imagine somehow skip the slicing software and program the exact movement of the toolpath. Like I would define positions in space for the tool to move. So let's say we have we divide an object in a certain number of points, and then we start moving these points selectively. So this is a simple version of what I was doing, but it's just an illustration to get the point. So if I alternate, for example, between moving points, let's say I move one and skip the next one and then move the next one, what you get is new points that don't fall on this initial circle and create instead these jagged lines. And if we start changing the pattern in which we selectively move the points, or even change the offset, like the amount of offset of these points, depending on other factors. Let's say how high we are on this object. If we are higher, the offset would be less. I'm just giving a few examples of random patterns, and this would actually result in different textures, different patterns on the texture, which is something I was interested in. And then you start being able to blend between patterns. Like if I would start from one specific offset pattern and mix it with another one as I go, as I print. These are some close-up photos of some of the objects I have in the exhibition space. There's the more regular or more geometric, and other times I was a bit more dependent also on the behavior of the clay. So the more organic and also prone to failures. Yana. here we can see the printing in real time. This is let's see, this is a 6 millimeter nozzle. It's the diameter of the plastic tip that you see there. Yeah, this is a 4 millimeter nozzle. So as you go lower, you can achieve maybe a finer details. The speed depends on many factors. So this was more or less my default speed, but depending on the material, whether or not it was wet or if the day is hot, or I would change the speed. Here you can actually see the whole object moving because my clay was a bit soft that day. Something I wanted to mention here is that the characteristics of the final surface, they cannot, accurately be predicted. So what I'm doing is I'm programming points in space that are mostly connected by linear segments. So anything beyond that, like how the material folds and drips and how these layers blend with each other, how they come together, is part of the unpredictability of the thing, which I was also interested in. I didn't really want to accurately guess what I'm gonna get, and this is something you can see in this mock-up. It is a mock-up of the same printed object that you see on the left, and this is this is as far as I could get to simulating it. So yeah, you can see that it's the same object, but really the qualities of the final surface cannot actually be seen before you print it. A few more experiments I did in order to get some input that I would apply to bigger objects. One is this self-intersection logic, where you get this sort of finger joint. Is this mine? You get this finger joint effect. In the beginning, I wasn't sure if this works, but it actually works, and the layers bind together. Holes to create perforated geometries, which is a challenge because as you move away from the previous layer, you have more chances of the whole thing collapsing. And also varying the Z height as you go. So instead of talking about planar sections, planar contours, there's this possibility of also changing the Z height as you go. And I worked a lot with spirals, and I have a couple of experiments with this effect here. So this is a custom machine, so it comes with its pros and cons. I'm gonna show you some of the cons. There were a lot of breakdowns. This is just one of the screws we destroyed and replaced. This happened a few times. So it bent under pressure, which means that either the clay was not soft enough or the nozzle was clogged. Usually it was one of the two. This is a 3D printed plastic part that exploded under pressure, and it exploded 4 times. Yeah. So then we decided to make it out of metal. This is Alex welding a metal version of it. Since then, this piece is still standing. So.
What process are you talking about?
Sorry?
What pressures are developing in that?
A number?
Well, if you have it.
I don't know. Anyway, as we went, I at some point I decided that it's part of the process to spend like a third of the residency resolving technical issues. This is after we assembled it. This is another plastic part that we replaced with a metal version of it. So I will quickly go through this final case study. This is something I was planning to have on display today. However, between the breakdowns and a lot of failed prints, this didn't happen. I have a few of the prototypes at the very end, and there's a chance I would maybe do this for the festival, for the RIP festival in October. This is this would be a small-scale version of an aquaponics system. So it is a cycle where the waste produced by fish provides nutrients for the growth of edible plants, and then the plants in turn purify the water of this system for the fish to live in. And it needs less water than traditional agriculture and not so much monitoring. Maybe Marius can tell us how much monitoring it needs. And so Marius was really helpful with this because he knows a lot about aquaponics. My version would be more like a tank size, aquarium size prototype. And it's a modular system where many of the steps of the cycle of aquaponics are being integrated into different modules that are somehow live together in the same water tank. And the approach would be that this is a sort of living sculpture. So these modules, they are fired and unglazed, which means that the clay is able to absorb organic matter, nutrients, and then it creates a favorable environment for the growth of bacteria, potentially growth of moss or other aquatic plants. And the weaving patterns that I was going to use here actually provide increased surface area for all these things. I'm not really going to get into details because I feel this is still under development. I've had I need maybe a couple more months to finish this. But you know, the module on top is where the plant grows, and then the plants grow, and then there's this cycle of water that goes through the elements one by one. Here you can see some tests I did for figuring out ways to assemble, because this is a modular system. So I wanted to just check how different ceramic parts can fit into each other. And then I would use some of these details in the actual bigger elements. And another challenge that came up is that when scaling up, everything changes. So the geometries need to be sort of treated like almost like an architectural scale geometry. So the shape you see on the top left, I could never print that. So it always collapsed. And then with the addition of these internal ribs, I would get the desired structure for it to stand. And this is a 30 by 30 by 30 centimeter piece approximately, is the one there. And this is the time lapse where it's being printed. And that's where the camera died. This is the base element of this system, which again, with the addition of these two incisions, 2 and 2 on the other side, I was able to have it standing instead of the first version that you see there. Still, this object is not perfect. You see that the right part is hanging, and eventually it broke, so it's broken. This is my very last slide. I want to thank you for joining today. Overall, I feel like I don't feel like this is a completed artist residency. I feel like this was like a preliminary research to get somewhere where I figured out a lot about printing with clay and the challenges that come with it. So in an ideal scenario, this is where I would start. Yeah, I want to thank everyone for coming. Thanks to everyone at Makerspace for putting up with my difficult ways. And yeah, if you have any questions, you can ask them now or at the exhibition over beer. Thank you.